A red dirt track runs across a flat gravel plain south of the McDonnell Ranges. To the left is an iron survey marker driven into the ground in 1968. To the right is a line of low saltbush that continues to the horizon without a dip, a creek bed, or an outcrop of rock. There is no fence, no change in soil colour, and no sign warning that the footing is unstable. 200 metres beneath that surface sits an empty cavern large enough to swallow an 8-storey office block. What is remarkable about the void is not merely its physical volume, but that heavy road trains loaded with cattle and diesel fuel drove directly over its roof for 43 years before anyone suspected the ground was hollow. For decades, official maps from the Northern Territory Department of Mines and Energy recorded the entire basin as solid, crystalline basement rock. The assumption was entirely reasonable at the time. Early seismic reflection profiles taken along the Stuart Highway in the late 1960s showed dense acoustic impedance with no anomalous reflections near the surface. The ground was logged as unyielding granite, but instruments calibrated for uniform geology routinely missed the structural cracks that form when subsurface water quietly dissolves ancient evaporite beds. Why did the standard geological survey maps across Central Australia fail to detect some of the continent's most unstable subterranean features until the ground physically collapsed? Across the continent, beneath roads, suburbs, and national parks, subterranean voids and abandoned industrial workings lie hidden just beneath ordinary topsoil. In the fifth part of this investigation, we will examine the buried shafts of the Victorian goldfields, where 19th century timber supports are rotting beneath modern suburban living rooms in Bendigo. Later in this series, we will trace the unmapped extraction stopes beneath Broken Hill, where heavy mining equipment operates directly above abandoned voids whose exact boundaries were lost when company records burned in 1928. Number 10. The Brewer Estate Sinkhole, Northern Territory. 12 kilometres south of Alice Springs, the Brewer Industrial Estate sits in what appears to be an unremarkable alluvial plain composed of quaternary sand and gravel. In April 2001, a routine drilling program conducted by the Power and Water Corporation to sink a monitoring bore struck a sudden loss of circulation at a depth of 42 metres. The drill bit dropped freely through 11 metres of open space. Subsequent microgravity surveys carried out by the Northern Territory Geological Survey revealed a network of solution cavities formed within the Cambrian-aged Bitter Springs Formation, where thick beds of gypsum and halite had been quietly dissolved by deep groundwater flow. The solid caprock supporting the industrial access road was less than 9 metres thick. Engineers immediately closed the road to vehicles exceeding 15 tonnes, discovering that vibrations from heavy transport had already caused microfracturing along the limestone roof. Number 9. The Mount Morgan Voids, Central Queensland. On the outskirts of Mount Morgan, 38 kilometres southwest of Rockhampton, an open-cut gold and copper pit that operated from 1882 until 1981 conceals a massive underground labyrinth. When mining shifted to open-cut methods in 1932, the excavation cut through hundreds of kilometres of older, undocumented underground drives and stopes. Today, the pit contains roughly 12 billion litres of highly acidic water with a pH of approximately 2.5. In 2012, geotechnical monitoring by the Queensland Department of Natural Resources and Mines revealed that water pressure was steadily weakening the fractured rock walls separating the flooded pit from the town's outer access roads. Subsidence sensors detected that ground movement along the western boundary was accelerating at nearly 2 centimetres per year as unsupported underground stopes began collapsing under the immense hydrostatic weight of the acidic lake above them. Number 8. The Nullarbor Railway Cavities, Western Australia and South Australia. The Trans-Australian Railway crosses roughly 470 kilometres of completely treeless limestone plain across the Eucla Basin. Built between 1912 and 1917, the line was engineered on the assumption that the vast expanse of Middle Eocene to Early Miocene limestone, known as the Wilson Bluff and Nullarbor limestones, was a uniform, monolithic slab. Surface runoff here is virtually zero because rainfall immediately drains through microscopic fissures. Over millions of years, rainwater charged with atmospheric carbon dioxide dissolved thick subterranean strata, creating miles of blind karst networks and shallow roof collapses known as blowholes. In 1997, geotechnical teams using ground-penetrating radar alongside the trackbed near Cook discovered that surface vibration from 3,000-ton freight trains was actively stripping gravel from track ballast into a previously unrecorded vertical cave system extending 40 meters down. In several sectors, track foundations were resting across limestone spans barely 2 meters thick, bridging cavernous rooms shaped by slow dissolution across 15 million years. Number 7. The Collie Basin coal voids, Western Australia. 200 kilometres south of Perth, the town of Collie sits directly over the Permian Collie Coal Basin, an isolated tectonic rift containing thick sequences of coal, sandstone and shale. Between 1898 and 1994, underground room and pillar mining extracted tens of millions of tons of coal, leaving extensive networks of horizontal drives beneath the town and surrounding forests. Early mining regulations permitted operators to abandon workings without backfilling, assuming the overlying Permian sandstone beds possessed sufficient compressive strength to span the voids indefinitely. That assumption failed as groundwater tables rebounded following the cessation of mine dewatering. Water saturation softened the porous sandstone pillars and underclay floors, initiating squeeze failures. In the Cardiff and Ewington sectors, continuous micro-subsidence began distorting regional drainage networks and tilting surface road bridges. Detailed mapping by the Geological Survey of Western Australia in 2004 established that over 4,000 hectares of historical workings remain flooded, unmapped, and subject to progressive structural creep. Number 6. The Ipswich coal tunnels, southeast Queensland. 40 kilometres west of Brisbane, the residential suburbs of Blackstone, Bundamba and Collingwood Park lie directly above the Triassic Ipswich coal measures. Late 19th century miners worked multiple dipping seams, including the Aberdare seam, often within 30 metres of the surface. As suburban development expanded rapidly across the region during the late 20th century, subdivision approvals proceeded on the premise that the historical workings were dry, stable, and accurately documented on state mining tenure maps. On the night of 28 December 1988, a sudden ground collapse in Collingwood Park damaged dozens of homes, cracking concrete slab foundations and fracturing underground municipal water mains. A comprehensive investigation by the Queensland Department of Resource Industries determined that the original colliery plans had systematically omitted illegal pillar extraction carried out during the final years of mining in the 1920s. Without those structural stone pillars, the overlying shales could not carry the weight of modern suburban housing estates. In April 2008, a second major subsidence event struck the same suburb, dropping a residential street by more than half a metre over 48 hours. How did modern surface survey techniques miss such massive structural deficits? And what happens when the ground beneath an entire populated region begins to sink simultaneously? Number 5. The Katherine Hill Bay extraction fractures, New South Wales. Along the coastal cliffs 80 kilometres north of Sydney, historical workings of the Wallara coal seam lie directly beneath residential streets and marine headlands. Mining beneath Katherine Hill Bay commenced in 1873, operating under the assumption that a 40-metre sandstone overburden was impervious to ocean water intrusion. In 2011, researchers from the University of New South Wales and the Geological Survey of New South Wales deployed airborne laser scanning alongside high-resolution electrical resistivity tomography across the coastal plateau. The resistivity profiles revealed severe subsurface voiding, where tidal action had infiltrated abandoned extraction panels. Unmapped mine drives driven beyond the high water mark in the 1890s had collapsed, allowing seawater to dissolve clay matrix minerals within the overlying Permian sandstone. The resulting tension cracks, invisible from the surface through dense coastal scrub, measured up to 18 metres in depth and ran parallel to the public roadway. Number 4. The Coober Pedy dugout labyrinths, South Australia. In the Stuart Ranges, 850 kilometres north of Adelaide, over half of the local population lives underground within the Cretaceous Bulldog Shale. What appeared to be an orderly grid of subterranean dwellings on municipal town planning charts masked a chaotic reality beneath the surface. From 1915 onwards, opal miners excavated dugout residences and illegal exploration tunnels without formal cadastral surveys, relying on handpicks and pneumatic drives. In 2006, the South Australian Department of Primary Industries and Resources conducted an extensive subsurface geophysical survey using three-dimensional ground-penetrating radar and borehole microcameras across the residential zones. The instruments identified more than 300 unmapped void extensions and undocumented exploratory shafts crossing property boundaries beneath sealed municipal roads and government buildings. In several locations, the sandstone roof separating private underground living spaces from heavy transport routes was less than 1.2 metres thick. Number 3. The Beaconsfield Fractured Serpentinite, Tasmania. In northern Tasmania, 40 kilometres northwest of Launceston, the Beaconsfield gold mine exploited quartz reefs hosted within complex Ordovician sedimentary and ultramafic rock sequences. For over a century, mining proceeded on the geological premise that the surrounding sandstone and limestone host formations were structurally competent when supported by standard rock bolts and mesh. On 25 April 2006, an intraplate seismic event measuring magnitude 2.2 triggered a massive rockfall 950 metres below the surface, trapping 2 miners inside an underground cherry picker cage for 14 days and claiming the life of another. A forensic geotechnical assessment by the Tasmanian Department of Infrastructure, Energy and Resources revealed that decades of deep pore water extraction had dramatically altered the hydrostatic pressure within surrounding serpentinite fault zones. The rock mass had undergone progressive, unrecorded microshearing, turning what appeared on drill cores to be solid crystalline rock into a brittle mosaic primed for catastrophic structural failure. When the physical ground beneath working towns fails under stress, how do emergency responders and modern civil engineers quantify the damage across areas where original survey records never existed? Number 2. The Broken Hill Line of Lode Stopes, New South Wales. In the far west of New South Wales, the city of Broken Hill was built directly alongside the world's largest known lead, zinc and silver ore body, hosted within the tightly folded Paleoproterozoic Williama supergroup. Starting in 1883, mining operations extracted over 300 million tonnes of ore along a 7-kilometre strike length. Early 19th century shaft sinking relied on square-set timbering using imported Oregon pine to support vertical stopes that plunged beyond 1,000 metres. By the late 20th century, deep groundwater pumping had dropped the regional water table, allowing atmospheric oxygen to enter the abandoned workings. The ancient timber supports began to dry, rot and compress under hundreds of thousands of tonnes of overburden. In the early 2000s, precise levelling surveys conducted by the New South Wales Department of Mineral Resources and satellite radar interferometry revealed continuous surface deformation across the central line of lode. A linear subsidence depression over 4 kilometres long was quietly settling at rates of up to 15 millimetres per year, threatening structural integrity along the barrier highway and fracturing buried sewerage networks across South Broken Hill. Modern remediation requires continuous satellite monitoring and multi-million-dollar grout injection programs to stabilise collapsing cavities that no living engineer has ever entered. Number 1. The Bendigo and Ballarat Goldfield Labyrinth, Victoria. In central Victoria, modern urban development across the cities of Bendigo and Ballarat rests upon what is arguably the densest network of abandoned deep lead and quartz reef gold workings in the southern hemisphere. Between 1851 and 1954, more than 5,000 separate mining shafts were sunk across the Bendigo goldfield alone, chasing vertical quartz saddle reefs down to depths exceeding 1,400 metres through the Ordovician Castlemaine group turbidites. When commercial mining ceased, hundreds of primary shafts and thousands of shallow unrecorded ventilation drives were simply capped with local hardwood timber logs and covered with half a metre of topsoil. Today, those timber covers have reached the end of their structural lifespan. The consequences are actively unfolding in established residential suburbs such as Golden Square, Long Gully and Eaglehawk. Since 2010, the Victorian Department of Energy, Environment and Climate Action and the Earth Resources Regulator have logged an average of 20 to 30 sudden shaft collapses each year across the region. In several instances, 5-metre-wide voids have opened without warning in backyards, school ovals and beneath suburban arterial roads following heavy winter rainfall events. When stormwater saturates the weathered clay cap, the rotting timber below fails under the added weight, sending tons of surface material plummeting dozens of metres into flooded 19th century workings. The exact number of undocumented shafts across Victoria's central goldfields remains unknown, with official estimates suggesting more than 10,000 forgotten openings lie scattered across private properties and urban reserves. Remediating a single collapse using reinforced concrete capping and engineered aggregate backfill typically costs state and local municipal bodies between $40,000 and $150,000. What does it mean for the future of regional infrastructure when the ground beneath generations of settled communities was engineered to be disposable from the very start? What kept these voids invisible for over a century was not their depth, but the administrative boundary between surface tenure and subsurface geology. Cadastral maps recorded property lines, road reserves, and freehold titles in 2 dimensions, treating the earth beneath as an infinite, unmoving anchor. The mining plans that documented the actual removal of stone existed in separate company archives, drawn on linen sheets that deteriorated, were lost during corporate liquidations, or were simply never lodged with colonial registrars. When towns expanded during the post-war building boom, municipal planners consulted the surface map and found no legal impediment to construction. The boundary of administrative responsibility ended at the topsoil. Today, state geological surveys and university research teams are using airborne laser scanning, satellite radar interferometry, and microgravity profiling to reconstruct what lies beneath urban Australia. But the task is fundamentally incomplete. Across central Victoria, northern Tasmania, and the Hunter Valley, tens of thousands of shallow shafts and extraction stopes remain unlocated, hidden beneath suburban lawns, paved roads, and regrowth forests. Geotechnical engineers can only model the probability of collapse based on rainfall thresholds and soil mechanics. The actual structural condition of 19th century timbering deep underground cannot be directly inspected without destructive drilling. In many areas, the surface ground will simply fail before the void beneath it is ever identified on a map. The published map sheet always looks finished. The ground beneath it is still moving, settling, and seeking its own equilibrium across deep time. Which forgotten mine working, sinkhole, or geological anomaly in your own state or territory has always seemed the most unstable to you? Share your observations in the comments below and subscribe for more deep documentary investigations into the hidden geography of Australia.